This video will cover two types of formulas, same row and multi-row. A commonly used method of data preparation is using existing fields to create new variables. Examples include adding, subtracting, multiplying, dividing, or applying another mathematical function to a numeric field, extracting and transforming substrings from a text field, extracting, truncating, and parsing date parts from a date field, conditional statements using if-then and binning to create new variables, and comparing values of two different fields to create a Boolean variable. Formulas can be used for adding, subtracting, multiplying, or dividing two numeric fields. In this table, we apply a formula to create the price column, which was calculated by dividing units sold by total amount. Formulas can also be used when applying a mathematical function to a numeric field. Examples of mathematical functions are average, floor, finding the smallest value, ceiling, finding the largest value, square, square root, absolute value, trigonometric functions, and logarithmic functions. In this table, we will create an observation average column using the average formula, which averaged values from the observation 1 and observation 2 columns. Formulas can also be used to extract and transform strings from a text field. There are a few common functions for transforming text, and they are typically named differently depending on the software package being used. The most common of these are upper-lower, used to change the field to all upper or lowercase characters, concatenate, which combines two or more strings into one field, substring, used to extract a portion of a string, trim, which can be used to remove certain characters, usually spaces, from a field, index, used to find the location of a certain string within a field, and length, which finds how many characters are in a field. These are the basic string functions that almost every software package will include and can be combined to complete almost any string transformation. For the following example, we will use two functions to transform a field that holds a city and state into two fields. To extract city and state from the airport location field, we would need to extract all the text before the comma as the city field and everything after the comma and space as the state field. To do this, we need two functions, index and substring. The index function will help us identify the location of the comma in the text field, counting from the left, including spaces. This is done because the comma is not always in the same location. Then we use the substring function to extract everything before the comma as the formula for the city field, and extract everything after the comma and space for the state field. To get the city and state columns back into the format of the original field, we would use a concatenate function. We can also use formulas for extracting, truncating, and parsing date parts from a date field. A date or date time field carries more information than a typical variable: the time of day, the day of week, the day of month, the month of year, the year number, and the difference in the date from other dates, such as today. Extracting this and other information out of a date field is a transforming technique that can add to the value of a dataset during analysis and reporting. The most heavily used date functions are today, used to get today's date, date part, used to get a part of a date, for example, getting the month of date will return the numeric value of the month, date truncate, which will return a date value at the beginning of a period specified, for example, truncating a date at the month level will return the first day of the month for the date, date add, which will add or subtract a certain number of periods to a date, and date difference, used to calculate the number of periods between two dates. This table contains the major holidays for 2016. For each date value, we can extract other features. We can add a column with a numeric value to describe the day of the week. We can subtract today's date from the date column to find the number of days remaining until the holiday occurs. With formulas, we can also compare values of two different fields to create a Boolean variable. A Boolean variable is typically used to capture true-false values. To create a Boolean variable, a logical statement or condition can be used in a formula. This logical statement can compare two values of the same type: numeric values, strings, and dates. This table depicts the population of states. We can use a formula to create a column that displays whether the state is on the East Coast. We can also create a column to display whether the state has a high population. Formulas can also be used with conditional statements such as if-then and when binning to create new variables. To create a variable with multiple possible outcomes, conditional statements are needed. These usually take the form of if condition 1 is met, then outcome 1. Else if condition 2 is met, then outcome 2. Else outcome 3. While the conditions within these statements are the same as Boolean formulas, these formulas offer more flexibility, as the analyst can assign any value when the condition is met, and can use as many conditions and outcomes as needed. While there are many applications of conditional statements, one of the most common is to bin or tile numeric variables, a process which transforms the continuous numeric variables into categorical variables. In this table, we compute sales volume with if-then logic. If sales is greater than 40,000, then high. Else if sales is greater than 20,000, then medium. Else low. This formula begins with testing the first condition, if sales is greater than 40,000, and if it is true, the first outcome high will be assigned. The second condition, else if less than 20,000, is evaluated only if the first condition is false. If the second condition is true, the second outcome, medium, will be assigned. If neither the first nor second conditions are true, then the final outcome, low, will be assigned. Sometimes data from a separate row or rows needs to be used when creating variables. For this, a multi-row formula is needed. A running total is the most basic multi-row formula. It adds the value of a field of a current row to the value of a previous row. This can be done across an entire dataset for a particular variable, or it can be grouped by certain dimensions. A lag value looks at the data in preceding rows, while lead values look at data in subsequent rows, and is the opposite of lag. Window functions provide the ability to perform calculations like sum, average, and rank across sets of rows that are related to the current query row. This is equivalent to aggregating the dataset across one or more dimensions, then joining the resulting dataset back to the original. This should be used carefully as values will be repeated for all levels of the dimension. An example of this is in the transportation industry, where a row typically represents one leg of a trip. After sorting the dataset properly, the lag function can be used to combine rows so that the data describing the round trip is displayed. Total price is a running total of ticket price, grouped by passenger ID. Notice how upon reaching the first row for a passenger ID, the sum starts over, and total price equals ticket price. Total flight time is a running total of flight time, grouped by passenger ID. Lag of destination uses the lag function, which doesn't consider any variables other than destination. This means it's dependent on the sort order of the dataset. Sum of ticket price is a window function, which is the sum of the ticket price partitioned or grouped by passenger ID. This concludes our video on single and multi-row formulas.